When a 1 mole of a liquid kept in a flask with a capacity 100 centimeter cube at 25 degrees centigrade, it eventually established a constant pressure of 24 mm of Hg. Hg means mercury. If a flask with a capacity of 200 centimeter cube were used instead, the pressure is. So in this question, so n is equals to 1 mole, small n is equals to 1 mole, and a capacity, here capacity means volume. So initial volume V1 is equals to 100 centimeter cube, and the temperature T is equals to 25 degrees centigrade. Here temperature is constant, so T is equal to 25 degrees centigrade, and constant pressure, so pressure P1 is equals to 24 mm of Hg. So we have to find P2, okay, and he also given V2. V2 is equals to 200 centimeter cube. So in this question, he given initial volume and initial pressure, and final volume we have to find final pressure. So here the flask with a capacity of 100 centimeter cube is replaced with a flask with a capacity of 200 centimeter cube. We have to find pressure P2. So in this question, temperature is constant. We didn't mention anything about temperature, so temperature is constant. So formula is P1 V1 is equals to P2 V2. So we have to apply Boyle's law. So Boyle's law. Okay. Now P1 how much? 24 into V1 100, P2 we don't know, and V2 200. So 100 ones are, 100 twos are. So 24 is equals to 2P2. Now 2 ones are, 2 12s are. Now P2 is equals to 12 mm of Hg. Okay. So the pressure is 12 mm of Hg. An ideal gas in initial state, 1 atmosphere, 273 Kelvin, 22.4 liters, is heated to 546 Kelvin. The volume of gas becomes 4.48 liters. The final pressure of the gas is. So here we have to apply ideal gas equation concept, and initial condition of the ideal gas T1, P1, V1. So T1 is equals to 273 Kelvin, and P1 is equals to 1 atmosphere, and V1 volume 22.4 liters. So initial temperature 273 Kelvin, initial pressure 1 atmosphere, and initial volume 22.4 liters. And given that this ideal gas is heated to a temperature T2 is equals to final temperature 546 Kelvin, and final volume V2 is equal to 4.48 liters. So we need to find final pressure P2. So just apply ideal gas equation formula. P1 V1 by T1 is equals to P2 V2 by T2. Now substitute all values. P1 1 atmosphere, V1 22.4 liters by T1 273 Kelvin is equal to P2. We don't know, we have to find. And V2, here V2 value is 4.48 by T2 546 Kelvin. Now let us make calculation, simplifications here. 273 2s 546. Okay. 2 1s are, 2 2s are 4, 2 2s are 4, 2 4s are 8. 1 into 22.4, 22.4 is equal to P2 into 2.24. Now transpose 2.24. P2 is equals to 22.4 by 2.24. Now P2 is equals to 22.4 means 224 by 10 by 2.24 means 224 by 100. So after decimal point we have two digits. We have to write two zeros. Here after decimal point one digit. So 1 0. Okay. Now 224 by 10. Division of fractions. Take reciprocal of denominator fraction. 100 by 224. So 224 cancel. 10 ones are 10 times R. Therefore, final pressure P2 is equal to 10 atmosphere. Now select the suitable option. P2 is equals to 10 atmosphere. A gas at a pressure of 5 atmosphere is heated from 0 degrees centigrade to 546 degrees centigrade and simultaneously compressed to 1/3 of its original volume. Find the final pressure. Okay. Here, initial pressure of the gas P1 is equals to 5 atm, means atmosphere. Okay. Now, this gas is heated from 0 degrees centigrade to 546 degrees centigrade. So convert centigrade to Kelvin. So simply add 273. So 0 plus 273 Kelvin. So here 546 plus 273. So how much 546 plus 273? 9, 11, 1, 819 Kelvin. So to solve this problem, we have to use ideal gas equation. Okay. So let us say initial volume is V, and this final volume, this volume is compressed to 1/3 of, final volume is 1/3 of initial volume. Okay. No? So simultaneously compressed to 1/3 of its original volume. So let us say original volume, initial volume V1 equal to V, and final volume 1/3 of original volume V. Okay. Now apply ideal gas equation. P1 V1 by T1 is equal to P2 V2 by T2. So here only unknown is P2. We have to find P2 value. In this question we should find P2. Okay. So this is the equation we are going to apply to solve this problem. Okay. Now substitute all values. So P1 5 atmosphere, V1 V by T1 273 is equal to P2 question mark, and V2 1/3 of V by T2 819 Kelvin. So VV get cancelled. Okay. So next we need P2 value here. So 5 by 273 is equals to P2 into 1 P2. So P2 by 3 whole divided by 819. Now apply crosswise multiplication. Okay. So 5 into 819 is equals to 273 into P2 by 3. So 3 1s are 3 9s are 27, 3 1s are 3. Okay. Now from this P2 is equals to 5 into 819 by 91. So 91 1s are and 91 9s are. Okay. So P2 is equals to 5 into 9. 5 into 9 how much? 45 atmospheric pressure, 45 atm. So answer is 45 atm. When the pressure on a gas is decreased to 1/4 and absolute temperature is increased 4-fold, the volume of the gas is. Okay. So first of all, here initial pressure P1 is equal to P, and final pressure P2 is equal to, so here pressure decreased to 1/4 of initial pressure, so P2 is equal to 1/4 P, and temperature, initial temperature, let us say initial temperature of the gas is T, and final temperature increased 4-fold, means 4 times, so 4 times of initial temperature. Let us say initial volume V1 equal to V, we have to find final volume. So simply we use ideal gas equation. According to ideal gas equation, P1 V1 by T1 is equals to P2 V2 by T2. So P1 is equal to P, and V1 is equal to V, and T1 is equal to T. And what about P2? P2 means 1/4 P by T2. T2 is 40 into V2. V2 is question mark, we don't know. Okay. So here PP get cancelled, TT get cancelled. So now V is equal to 1 into V2 by 4 whole divided by 4, or we can write 4 by 1. Now V is equals to V2 by 4 into reciprocal of 4 by 1 by 4. Now V2 by 4 into 4, 16 is equal to V. Now transpose 16. V2 is equal to 16 times of V. Okay. So therefore final volume is 16 times of initial or original volume. 16 times of initial volume. Okay. This is the final answer. The density of CO2 gas at 27 degrees centigrade and 1 atmospheric pressure is in gram per liter. So here density of CO2 gas. So rho, or we can take d, small d. D for density, or rho you can take. D is equals to how much? Density of the density of CO2 gas at 27 degrees centigrade and what 1 atmospheric pressure is in gram per liter. So we have to find density of CO2 gas. So D is equal to density denoted by D. D is equal to question mark. We have to find density of CO2 gas. And the given temperature T is equal to 27 degrees centigrade. So convert it into Kelvin. So add 273. So 27 plus 273, 300 Kelvin. Next, pressure P is equal to 1 atmosphere. So we have a formula for using ideal gas equation. We have formula for density of gas. D is equals to, what is the formula? Pm by RT. Density D is equals to Pm by RT. Density of a gas, ideal gas, equal D is equals to Pm by RT. So here P is pressure and M is molecular weight of given gas. So molecular weight of CO2 how much? Carbon 12, oxygen 2 oxygen. So 2 into 16. So 12 plus approx 32. So you will get 44. Molecular weight is 44. And P is 1 atmosphere and R, universal gas constant, R is equal to 0.0821. Okay. So now substitute all these values, and T1 is equal to, T is equal to how much? 300 Kelvin. Now D is equal to P1 into M 44 by R 0.0821 atmospheric pressure. In terms of atmospheric pressure and liters, we have a unit R equal to 0.00821 into temperature 300. So 1 into 44, 44. 0.0821 can be written as 8.21 by 100 into 300. 0, 0, 0, 0 get cancelled. 44 by 3 1s are 3, 3 2s are 6, and 3 8s are 24. So 44 by 24.63. So if you calculate, you will get 1.78 gram per liter. This is the density of given CO2 gas at 27 degrees centigrade and 1 atmospheric pressure. If the pressure of a gas is reduced to half and the absolute temperature is double, the volume will be, okay, question mark. So initial pressure, let us say initial pressure of the gas is P and final pressure is half of the initial pressure, means of P, and initial temperature, let us say T, and final temperature is doubled, means 2T. Let us say initial volume is V or V1. Let us say V1 equal to V1 and V2 is equal to question mark. So we have to find relation between V1 and V2. Simply apply ideal gas equation. P1 V1 by T1 is equals to P2 V2 by T2. So P1 is P and V1 is V1 and T1 is T. P2 half of P V2 by T2, 2 times of T. T2 get cancelled, PP get cancelled. Now V1 equal to V2 by 2 whole divided by 2 can be written as 2 by 1. Now V2 by 2, take reciprocal of denominator, 1 by 2 denominator fraction. So 1 by 2, multiply numerators and denominators separately. V2 into 1, V2, 2 into 2, 4. Now V2 is equal to transpose 4. Division becomes multiplication. You will get 4V1. 4 into V1. So it means volume will be increase. How many times? 4 times. Okay, na? Volume increase 4 times. This is the final answer. The density of a gas at 27 degrees centigrade and 1 atmospheric pressure is 0.027 gram per milliliter. Evaluate its molecular mass. So here density of a gas D is equals to 0.027 gram per milliliter. So D is equals to 0.027 gram per milliliter can be written as 10 to the power of minus 3 liters. Now, so here we are going to convert gram per milliliter to gram per liter. So milli means 10 to the power of minus 3. Now take this 10 to the power of minus 3 from denominator to numerator. Now it becomes 10 to the power of plus 3 gram per liter. Now 0.027 means 27 by 10 to the power minus 3 becomes plus 3. So 0.027 means 27 by 1000 into 10 cube. 10 cube also 1000. So 1000 get cancelled, gram per liter. So therefore density is equals to 27 gram per liter. And given temperature T1 is equals to, or T, let us say T, 27 degrees centigrade. So convert it into Kelvin, you will get 300 Kelvin. And P1 or P, simply we say P, pressure how much? 1 atmosphere. Pressure 1 atmosphere. We have to find molecular mass. Molecular mass, okay, or molecular weight, M, you have to find M. So we know that molecular mass M is equal to dRT by P. So here D means density of gas. Density of gas is 27 gram per liter into R means universal gas constant. So its value is 0.0821. Okay, na? So if given values are in liter and atmospheric pressure, then we consider 27 at 0.0821 into temperature 300 Kelvin by pressure 1 atmosphere 1. Let us simplify further. So M is equal to molecular mass, M is equals to 27 into 0.0821 can be written as 8.21 by 100 into 300. Okay. So 0 get cancelled. So 100 ones and 100 threes. Now 27 into 3 how much? 81. 81 into 8.21. So M is equal to 81 into 8.21. If you calculate, you will get 665.01. This is the approximate value of molecular mass of given gas, 665.01. A gas was compressed to half its original volume at 300 Kelvin temperature. Assuming the pressure is constant, at what temperature will the gas have its original volume? So here let us say initial volume of gas V1 is equals to V. Now this gas is compressed to a volume of V by 2. Half of its original volume means V by 2, and the temperature T2 is equal to 300 Kelvin. Okay, so here T1 is equals to question mark. We don't know what is the initial temperature of the gas, but here pressure is constant, P1 equal to P2. So we have to find at what temperature will the gas have its original volume. So it means we have to find value of T1. So apply ideal gas equation. So P1 V1 by T1 is equals to P2 V2 by T2. So P1, so here P1 is equal to P2. Now P1 P2 get cancelled and V1 is equals to V, and T1. So T1 we have to find value of T1, and V2. So V2 is half of its original volume V by 2, and T2 is 300 Kelvin. Now apply crosswise multiplication. So before that, here VV get cancelled. Now 300 is equals to T1 into 1 by 2. Now transpose 2. Then T1 is equals to 300 into 2. You will get 600 Kelvin, or in degree centigrade 600 minus 273. So 600 minus 273 means you will get 327 degrees centigrade. So in Kelvin 600 Kelvin, in degree centigrade 327 degrees centigrade. A gas occupied a volume of 250 ml at 700 mm mercury pressure and 25 degrees centigrade temperature. So your initial volume of the gas is 250 ml at 250. Initial volume is 250 ml milliliters, and pressure P1 is equals to 700 mm of mercury Hg, and temperature T1 is equals to 25 degrees centigrade. So convert it into Kelvin. 25 plus 273, you will get T1 is equals to 298 Kelvin. How much additional pressure is required? So we have to find how much additional pressure means change in pressure. Additional pressure, additional means change in pressure. Change in pressure means P2 minus P1. How much additional pressure is required to reduce the volume of a gas to, so 4 by 5 or 4/5 of its original value. So initial pressure is V1, so 4/5 of V1. Okay, so we have to find additional pressure required to reduce the volume of gas to 4/5 of its original value at the same temperature. So T2 is equals to T1. So this is the given data. First of all, to find P2 minus P1, we need P2. Now apply ideal gas equation. Okay, so P1 V1 by T1 is equals to P2 V2 by T2. Here temperature is constant, so T1 T2 get cancelled, and P1 is 700 into V1 250 ml is equals to P2, we don't know, and V2 4 by 5 into V1 how much again? 250. So 250 get cancelled. Now this 700 is equal to P2 into 4 by 5. Okay, now 2 2s are, and 2 350s are, and 2 1s are, 2 175s are. Okay, now P2 is equals to 175 into 5. So 5 5s are 25, 2 carry forward, 5 7s are 35, 2 37 3, 5 into 5 8, 875 mm of mercury. So P2 value is 875 mm of mercury. Now we want delta P. Delta P equal to P2 minus P1. P2 is 875, P1 is 700. Now delta P is equal to additional pressure required is 175 mm of mercury. So this is the final answer, 175 mm of mercury. Under identical conditions of temperature, the density of gas X is 3 times that of gas Y. So density of gas X dx is equals to 3 times of gas Y dy, where molecular mass of gas Y is twice that of X. Molecular mass of gas Y is twice, 2 times that of X. The ratio of pressures of X and Y will be, so we have to find Px by Py ratio, Px by Py. So we know that density of gas D is equals to, what is the formula for density of gas? Pm by RT. Okay, so given that identical condition of temperature means temperature is constant. So first of all, dx is equal to what? Dx is equals to px mx by r tx, and dy is equals to py my by r ty. And remember, under identical conditions of temperature means temperature is constant. So here tx is equals to ty, tx is equals to ty. Okay, now let us find the ratio. Okay, before that, here px can be written as px is equals to what? Dx rtx by mx, and py is equal to what? Py dy rty by my. Okay, so now find ratio px by py, px by py. Now what is px? Dx rtx by mx whole divided by dy rty by my. Now here tx ty get cancelled, rr get cancelled. Now dx by mx into reciprocal of dy by my by dy. So here dx by dy into my by mx. Dx by dy how much? Dx by dy is 3 and my by mx is equals to 2. Now 3 2s are how much? 6. Therefore px by py, ratio of pressure of x and pressure of gas x and pressure of gas y is 6 is the final answer.